Welcome viewers, in this video we will see the details about 1:4 demultiplexer. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic 1:4 demultiplexer. Demultiplexer is nothing but having one input and 2 to the power n output. One input and 2 to the power n output and having n number of selection lines. This selection line will decide the how this selection line is used to produce the 2 to the power n outputs. From one input 2 to the power n outputs are produced by the selection line. So here 1:4 means it is 1:2 to the power 2, n equal to 2 here, right? So that we have two selection lines. One input 2 to the power 2 means 4 outputs and two selection lines are available in the 1:4 demultiplexer, right? Now we'll see the diagram show 1:4 demultiplexer. We'll see the diagram later. The single input variable is din, has a path to all 4 outputs, right? The single input is din. Din is nothing but a input data that is connected to all 4 outputs. But the information is directed to only one of the output line depend upon the selection line, right? The input is connected to all the circuit, but which one is enabled, that is decided by the selection line. And also we have enable input should be high to enable the demultiplexer. If enable is high, the circuit will be activated. If enable is 0, circuit will be deactivated, right? So we have one input, 4 outputs. This one input is routed to 4 outputs based on the selection line. The selection line will decide which one will be available as the output out of 4. Then also we are having the enable input. Enable input enable the demultiplexer, otherwise the multiplexer will be deactivated. Your enable input is 0. Now we'll go to the truth table. 1:4 multiplexer, the truth table. So this is the enable input E. The selection lines, selection input S1 and S0. This is the input data dn. This is the output Y0, Y1, Y2 and Y3, right? The Y0 is the LSB, Y3 is the MSB, right? Enable, selection input and outputs. If enable is 0, whatever may be the selection line, whatever may be the data input, all outputs are 0. That is, circuit is not enabled. It will produce only 0. Suppose enable is 1. In that case, we will go to the remaining. Here all are enable is 1. So the selection line 2 bit data S1 and S0. So that 4 combinations are available: 0 0, 0 1, 1 0, 1 1. In that 0 0, again there are 2 possibilities. The data may be 0 or 1. The data may be 0 or 1. So that we have 8 possibilities are available. First we will see the 0 0, first combination. 0 0, if the data input is also 0 means all are will be 0 only. Suppose the data input is 1 means the first position will be 1. Remainings are 0. The input data 1 is routed to the first position if the selection line is 0 0, right? D in is routed to Y0, right? We have only one input. That input is may be available in first position or second position or third or fourth position. For 0 0, the input 1 is available at the first position. Then we'll go to the next one. 0 1, input is 0 means everything will be 0 only. For 0 1, input is 1 means it is the input is routed to the second position Y1, 0 1 0 0. See here it is 1 0 0 routed in the first position Y0. For 0 1, the input is routed to the second position Y1, right? So that we got 0 1 0 0. Then third combination 1 0. If the data is 0, totally everything will be 0. If the data is 1, then input is routed to the third position Y2, 0 0 1 0, right? D in is routed to Y2. The last combination 1 1. If the data is 0, everything will be 0 only. If the data is 1, it is routed to the fourth position Y3, right? 0 0 0 1, right? So we have only one input. For 0 0, it is routed to first position 1 0 0 0. second combination 0 1 means 0 1 0 0, third means 0 0 1 0, fourth means 0 0 1 1, right. See, this 1 is available in first position, second position, third position and fourth position, right. So available one input is placed in the 4 different combination, that is 1 0 0 0, 0 1 0 0, 0 0 1 0, 0 0 0 1, that is input is positioned in first position, second position or third position or fourth position, so that we got the 4 different output, right. So for the first position it is 0 0, for second position 0 1, third position 1 0, fourth position 1 1, right. So based on that we will see the logical expression and logical diagram. So this is the logical expression. 0 0 means S1 bar, S0 bar. 0 1 means S1 bar, S0. 0 refers bar complement. 1 0, 1 means S1, 0 means S1 bar. 1 1 means same it is S1 and S0, right. So in the every case we have D in is a input. Now we will see the logic diagram. So we have the selection line S0 and S1. This green color is the selection line. This red color is the selection line S1. This is S0 and S1, right. So with the tapping is taken and one NOT gate is connected. So that S0 mean after the NOT gate we got S0 dash. Similarly in the S1 one tapping is taken and is connected to the NOT gate. S1 means after the NOT gate it is S1 dash. So we have 4 possibilities. S0, S1 is available, S0 dash, S1 dash also available. Using the NOT gate we got the complement also available. So this is the data input DN, right. We have 4 AND gates are available. 4 AND gates are connected in order to produce the 4 different output, right. So in the all 4 AND gate the DIN is connected, data input is connected, right. The one input is data input and also it is connected with the enable line. So it is enable line is the second input. If the enable is 1 then only they will produce output. If enable is 0 means because of NOT gate every output will be 0, right. Enable should be 1, right. So we have 4 input, out of 4 input, one input is the data line, second input is the enable line, right. Third and fourth input is this selection line S1 and S0. We will see how it is produces, right. So we already discussed why not placed in first position mean the input will be 0 0, the selection line will be 0 0 means the Y naught will be activated, right. If it is 0 0, S1 is 0 mean S1 bar will be 1, S0 is 0 mean S0 bar will be 1, right. For a selection line 0 0 we got the Y0 output. 0 0 means S1 bar and S0 bar become 1 1, already enable is 1 and DIN is available, right. So all 3 inputs are active high, so the DIN will be available at the output. For that case 0 0, right, because we are connected in such a way that 0 0 means it is connected with complement S1 bar S0 bar, so that 0 0 automatically become 1 1, right. But second case 0 1, 0 1, in that we are getting the second output. We already discussed in the truth table. 0 0 mean first position, 0 1 second position, 1 0 third position, 1 1 mean fourth position. The first position we discussed. 0 1 means what will happen? S1 is 0 mean S1 bar will be 1. So S0 is already 1. Enable is also already 1. See this, S1 is 0 but we are connected S1 bar. Here S1 bar is connected, right. So the S1 bar, this is the S1 bar is connected. S1 bar is connected, so that we are getting, so it's not connected here, it should be connected here. So it is here, here it is same, S0 and S1 is connected. So here it is connected with the S0. So we have all 3 inputs are active high, so automatically DIN is available at the output in case 0 1. Now 1 0, if it is 1 0, right. See here S1 is connected. here connected with the S1. This is S1 and this is S0 dash, not here. Here S0 dash is connected. So S1 is 1 means the S1 will be 1. S0 is 0 means S0 dash become 1. Already enable is 1. Right. So that automatically D in will be available at the output in case 1 0. Right. The remaining will be automatically 0. For case 0 0, here this is will be 0. So automatically the remaining outputs are 0. Right. So for 1 0 only this output will be available. Remaining will be automatically 0 because AND gate any one input is 0. Totally it will produce 0 0 0 1. We will see this 1 0 means see here S1 is 1 mean S1 bar will be 0. So totally it become 0. Right. So for this combination only one this output will be produced, other outputs are 0. The finally we have 1 1. So it is connected directly S1 and S0. So it is connected direct. So this is correct only. This is correct, here also correct. This is connected S0 and S1. Right. So already enable also 1, S1 also 1, S0 also 1. So automatically we get D in as a output. Right. So in this case S0 is 1. So S0 dash will be 0. So this gate will be the output of AND gate is 0. Similarly here S1 is 1. S1 bar is 0. So this output also 0. Here both are 1 1. So while taking complement it becomes 0. Both are the output will be 0. Right. So for this combination only this NOT gate will be produced, this AND gate will produce the DN. Remainings are 0. Similarly for 0 1 only this AND gate will produce the output Y in. Remaining outputs are 0. Similarly for 1 0 this NOT gate will produce D in, third position. Remainings are 0. Right. Similarly the fourth for combination 1 1 this AND gate will produce the D in output. Remaining output 0. For example 0 0 mean this output will be 1. Remaining outputs are 0 0 0. For second combination this output is 0, only this output will be 1, remainings are 0. For third combination this output will be 1, remainings are automatically 0. For fourth combination only this output is 0, remainings are 0 because it is connected S1 bar S2 bar, right. S1 and S0 is 1 mean automatically S0 becomes 0, so total is 0. Here one S0 S1 dash is S1 bar is there, so that also 0. Right. So because of the connection, based on the connection S1 or S1 bar, automatically the remainings are 0. Right. So for 0 0 we got this 1 0 0 0 first position. 0 1 means we got the output at second position. 1 0 mean we got the output as third position. 1 1 mean we got the output at fourth position. So in this video we discuss about how to the working principle of the 1:4 demultiplexer, having one input and 2 to the power 2, 4 outputs. So this one output is routed to the fourth position, either first position or second or third or fourth position, that is decided by the selection line. We discuss the truth table, then we frame the Boolean expression. That expression is implemented with the logic gates. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.